Looking at the unit circle is on the XY axis. The unit circle is centered at the origin, 0, 0, and also has a radius of 1 for the circle. So the four endpoints are 1, 0, 0, 1, -1, 0, and 0, -1. If you look at the first quadrant, which is in the top right-hand corner, starting on the inside of the unit circle, 0 degrees starts on the x-axis, and as you go around counterclockwise, the degrees increase. The first 3 degrees will be 30 degrees, 45 degrees, 60 degrees, and 90 degrees. It'll continue around the circle until you make one full revolution, which will be 360 degrees. Instead of degrees, you can also use what's called radians. Radians again start at 0 on the x-axis and increase as you go counterclockwise. The first radian is pi over 6, then pi over 4, pi over 3, and pi over 2, and it continues all the way around until you have 2 pi, which is the distance around the circle in terms of radians. The endpoint again, the first point is 1, 0, and then you have 3 fractions that represent the points for the degrees and radians, and then the top point is 0, 1. Looking at the 3 fractions or 3 sets of points, every number x and y is a fraction over 2. The numerators also have a pattern, which is a U shape going from top to bottom and back up to top. It goes in order of 1, 2, 3, and counts back up for the y values of 1, 2, and 3. The numerators all have a square root on top, except for the 1s, which if you take a square root of 1 would simplify to just 1s. The other points directly across and directly below are the exact same points, with positives and negatives represented for the x's and y's. Title of the first section today is Changing, Degrees, and Radians. In this section, we'll look at how to change degrees to radians and also radians to degrees. The one definition or step that we'll use for this section is multiply by pi over 180 degrees, or the reciprocal of that, 180 degrees over pi. If you look at the unit circle, halfway across the unit circle, the pi matches up with 180 degrees, so these two units are equal, and also 180 degrees over pi, both units are equal. So by multiplying by pi over 180, or 180 over pi, we're basically multiplying by 1. First question we'll look at is 130 degrees. We'll take the degree measurement and we'll change that into radians. Instead of a degree symbol, radians will be left with a pi symbol. To change degrees into radians, we'll multiply by either fraction. The fraction that we want to use, if we start with degrees, we want to use the fraction with the degrees in the denominator. So we'll multiply by pi over 180 degrees. Multiplying, the degrees would cross cancel. You could also divide by 10 or cross out the zeros, and we'll be left with 13 times pi divided by 18. And what this means is 130 degrees is the same as 13 pi over 18. Second question, and last question for the section, 3 pi over 4. In this case, we'll start with radians. Radians, again, always have a pi measurement, and we'll change radians into degrees. To change the units again, we can multiply by a fraction. Whichever units we start with, in this case we start with pi, we want to have pi in the denominator so we can cancel out the pi's and we'll be left with degrees. So the other fraction that we can use is 180 degrees over pi. Multiplying or reducing, the pi's again will cross cancel. So our final units will be left with degrees. You could multiply 3 times 180 divided by 4. Or if you want to cross cancel the 180 and 4. Taking 180 dividing by 4 would be 45. And we'll be left with 3 times 45, which will be 135 degrees. So again, what this means, the radians 3 pi over 4 is the same as 135 degrees. And looking at the unit circle in quadrant 2 in the left-hand corner, if you find 135 degrees, it is equivalent to 3 pi over 4. Title of the last section today is Finding Positive and Negative Coterminal Angles. In this section, we'll find a positive coterminal angle and a negative coterminal angle. A coterminal angle means the same angle, but written as a different fraction or different number. The definition or way to find coterminal angles is add / subtract 360 degrees or 2 pi. Looking back at the unit circle, 360 degrees is one entire revolution, and 2 pi is also one revolution around the circle. So if you add 360 degrees, you'll end up at the same spot, or if you add 2 pi, you'll end up at the same spot on the unit circle. With subtracting, you'll go clockwise around, but again, you'll end up at the same exact spot on the unit circle, which will give us a coterminal or equal angle. First question is 225 degrees. For 225 degrees, we want to find one positive coterminal angle, which will be a positive number, and a negative coterminal angle, which will be a negative number. We can first add 360 degrees to get a positive coterminal angle. 225 plus 360 would give us our first answer of 585 degrees. What that means is 225 degrees is the same as 585 degrees, except 585 degrees has one extra revolution around the circle. To find a negative coterminal angle, we can take the original angle of 225 degrees, and instead of adding 360, we can subtract 360. 225 minus 360 would be negative 135 degrees. So for the angle 225, a positive coterminal angle is 585, and a negative coterminal angle is negative 135. Second question is the radian measure 3 pi over 4. Taking the radian measure of 3 pi over 4, we can find a positive and negative coterminal angle that is still in terms of pi or in terms of radians. Instead of adding 360, when we have the units of pi, we can add 2 pi. And again, 2 pi is the same as 360. It's one revolution around a unit circle. 3 pi over 4 plus 2 pi. If we make them fractions over 1, we can get common denominators and add from here. 3 pi over 4 would stay the same. Plus, changing to a common denominator, we can multiply by 4. So 2 pi over 1 is the same as 8 pi over 4. Adding straight across, we'll have 11 pi over 4. And that'll be our positive coterminal angle. 11 pi over 4 is the same as 3 pi over 4, except 11 pi over 4 has one extra revolution around the circle. To find a negative angle, we can take the original angle again in radians, 3 pi over 4, but instead of adding 2 pi or adding 8 pi over 4, we can subtract 8 pi over 4. 3 pi minus 8 pi would be negative 5 pi over 4. So we have one positive and one negative coterminal angle for the radian measurement 3 pi over 4. And last angle we'll look at is 400 degrees. Again, to find a positive coterminal angle, we can first add 360 degrees. 400 plus 360 would be 760 degrees. So a positive coterminal angle of 400 degrees is 760 degrees. To find the negative, again, we can take the original angle. Instead of adding, we can subtract 360 degrees. 400 minus 360 would be 40 degrees. Again, we want a negative coterminal angle, which means the answer should be negative. Anytime you subtract 360 and you have a positive number, if we want to get a negative number, what we can do is take our answer 40 and subtract 360 again. Each time we subtract 360, we're taking away one revolution from the circle. So if we subtract once, it's still positive. We can subtract a second time, and we'll still be at the same spot on the unit circle, but it will be one less revolution. So 40 minus 360 would be negative 320. So a positive coterminal angle would be 760 degrees. We could also use 40 degrees as a positive coterminal angle, and the negative coterminal angle would be negative 320.